Clarifying questions, slowly moving towards discussion. We will try to keep microphone as far as we can.
Because of the video.
Yeah, because we will have
Okay. For my understanding, the bootstrap results, are they the same as the sampling distribution of the mean?
What you do is, you're asking about the working of the bootstrap distribution?
Yeah, what is the result? Where can I compare it with? Because in your explanation, we had when we have a familiar population.
Yeah, a known population.
Take a sample and we get, of course, sample distribution of the mean.
A sampling distribution. Yeah. These are all results of samples. Yeah.
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 And when you use the bootstrap, do you get more or less this distribution?
Yeah.
Okay.
Exactly.
Yeah.
This is a sampling distribution. So this was about a proportion of 500 kids. Many times 500 kids surveyed, all kind of proportions, right? We can do the same with the bootstrap. What we have then, we get a bootstrap distribution. And it actually looks similar. Also all those results. Something like this. And we can, again, calculate 95% confidence intervals, etc.
So we have a different path coming to the same distribution. And we should learn anyway our students to handle and use this kind of distribution for their statistical reasoning.
Yeah, I would say that because what we do in building block 2 is this, right? We explore sampling distributions. Then we come to building block 3, we want to learn them real inferential statistics with an unknown population distribution. And then we have the bootstrap method, which is very nice because it gives about the same distribution, right? It's very similar. Yeah? Shall I explain what bootstrapping is? The idea is that you have your sample of 500 kids. So n is 500. So all kids, right? And there are ones and zeros, one. My parent is addicted, my parent is addicted, mine is not, 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 mine is, etc. Right? 500 kids, 1 or 0. And in the sample it's 1/3. And what we say is, and I have a slide somewhere, over here. What we say is, the population is to the sample as the sample is to the bootstrap population. Let's treat, what we did here was, we have our population, and we draw a sample out of it, another sample, we create this one. What we do over here is, let's assume that this is my population, draw a sample from, again, 500, but now with replacement. So I want to have 500 children, random sample, 500 children, so I take one, it's a 1. I put it back, another one, it's a 0. Another one, it's a 1. And I calculate the proportion of those 500, that's a bootstrap sample, right? A sample from my sample is a bootstrap sample. And I calculate of that sample of with replacement, the proportion, and put it over here. And I do it again. And I do it again, and do it again, and I get my bootstrap distribution. And what I assume here is, and it took me about 1.5 years to understand this process, so don't try to fully understand it in 3 minutes, maybe. The assumption here is that I don't know my population distribution. So still, I want to say something about my population. And now I feel like a statistics teacher again. And the only thing I have is my sample, 500 students. Assuming that this is a representative sample, which I can assume because it's a random sample, we're only talking about random samples. Assuming it's a random sample, I think this is the best estimate of the population distribution I have. And what happens when I draw random samples with replacement, again of 500 from this, I get again a distribution around 1/3, but with some margin of error. And that margin of error is what I'm interested in inferential statistics, right? I want to have an interval estimation, so I need a margin of error. And to appreciate the margin of error, of course, you have to be, aware of the relevance of that margin, right? So if you don't know this method, I can't convince you or explain it in a couple of minutes, but I can assure you that this is just a statistically completely valid method, often used in statistics, also advanced statistics.
And the regions, are they similar then?
The regions are indeed similar.
The region that the
interval.
Well, is it similar to the first one?
Yeah, and as long as your sample, you do enough repetitions, enough resamples, and as long as you have enough categories on your x-axis. But that's a bit technical.
Okay.
Yeah. And it's pulling yourself up by the bootstraps, right? And that's the funny thing. Bootstrap means, it comes from pulling yourself up by bootstraps, which is impossible, of course, right? But still, we have to do something, and we only have our sample. And rather than using this drama of distributions, with all those exceptions, right, boom, we have something easier. It looks so similar, and the only thing we have to do, we don't need degrees of freedom, we don't need formulas, we just simulate and say, 95%, 99%, 90%, whatever, right? That's the easy thing. And of course, we can go on and make it a bit more complex, but actually it doesn't really become more complex.
More of clarifying questions? Yeah.
What kind of probability do students need to know when using informal statistics until, well, upper secondary school?
Upper secondary school. That's one of my questions. What is the role of probability theory in primary and secondary education? I don't think there is much role left for, but please comment on this. I don't think there is much role left for probability theory as a support for inferential statistics. Maybe only on its own, right? If we think it's important that students or citizens should be able to reason probabilistically, right? Then we should teach them that. But otherwise, I don't think for inferential statistics. Although we need, of course, some basic intuition for probability to understand what's happening over here, right? But the technicalities, we don't need for inferential statistics. But please comment on that, because
yeah,
I'm not
I
so
actually
sure
want to
yet.
continue my question immediately here, then pass to you, okay? You have a question, Monica, yeah?
Yeah, but it's not a clarifying question, it's a discussion point. So.
Yeah. Yeah, okay, then may I continue also more of a discussion exactly on that? I'm actually a bit puzzled. I've been teaching inferential statistics for psychology students for years, and also I know the trouble that psychology as a science has is that they actually run conclusions on one sample. And this is a disaster because the whole field goes somewhere in the wrong direction due to this. Yeah. So the main trouble that I'm trying to deliver to my students is that when you have one sample, you can make conclusions, but they are very limited because you don't know a population and all of it. So this is a kind of a message. And I have a feeling with this bootstrapping, which I certainly don't deeply understand, you kind of trapped with the same problem. You do not trouble this issue, you rather even make it stronger.
Well, what I do with the bootstrapping, with resampling methods, is replace the traditional approach with a different approach that helps to answer a specific question, how can I make an inference about a population based on one sample? So it's indeed a bit narrow question. And the issue you raise is more, I think, about a bit broader and maybe even a bit more methodological. What's the value of one sample, right? Mm-hmm. So I fully agree with you that we should be very careful what we say based on one sample methodologically, but not statistically, right? We just have sound statistics to make, if we assume the sample is representative, and we can, when it's a random sample, then we can use techniques like this to create a confidence interval. That's the only point I'm making, right? And all the methodological issues, indeed. This is a statistical, a bit narrower.
I just think that this if this sample is random, it's a very big if.
Yeah, very big, very good point. Very big if, yeah.
Yeah, I think that is the issue. It is not random, but I would raise another issue. That is that in many research nowadays, we say we should not use p-values and hypothesis testing in this traditional way. Especially the people from the University of Leiden, like Peter Grunewald, they have a different approach of hypothesis testing that allows you to include more people in your sample after that you have drawn conclusions, and that makes it stronger.
Yeah.
And I do not see that back in education, in statistics education yet. Shouldn't we just leave this path and go to these other techniques?
Well,
so that's my question.
I can't answer the question yes because I don't know that these techniques that well. Yeah. But this is given your question. How can we best teach this? And I think that this is what I argue is that using resampling approach is better than a traditional approach. But it leaves aside all the drawbacks of using hypothesis testing. Yeah. And alternatives to a more limited approach. Yeah.
But generally, if I kind of rephrase Lonika's narrow question to a bit broader, yeah, there are clearly some, what you say, methodological movements in the use of inferential statistics generally in science. Do you think we should infer from that some changes in already secondary education?
I have no opinion about that. I'm not an expert in that field. Yeah, I'm just moving away a bit of this methodological issue because this is what I've done, right? And this is also my expertise, right? How do we teach inferential statistics? And your question is more about how do we actually do research using inferential statistics? And I think, and next question is how do we teach it? And I don't have an opinion about what kind of inferential statistics and sampling techniques should we use? No? You don't agree?
No, I don't agree at all. I don't agree at all. I think it's not an issue of methodology. I think it's an issue of what kind of statistics do you want to teach? Because it's a different kind of statistics.
Excuse me, what is a different kind of statistic?
Like the statistical techniques that they use at the University of Leiden, like Peter Grunewald.
Yeah. I don't have an opinion about that. I don't know
but as you suggest a learning trajectory, I think you should consider that.
I fully agree.
In the future.
Yeah, thank you. Good suggestion.
Well, maybe my argument is in between you two, I don't know. When you read the literature, you should focus on the need for a sample. So the need for data. And when I read it, I think it's exploring data, it's visualizing data, but shouldn't we start with asking a question, or students have a question and they need statistics to solve their question, to solve their problem. Yeah. So to focus more on a problem than specific on the statistical methodology. So maybe that's a bit in a way you're thinking that it's part of a whole research, a whole cyclus of.
Yeah.
So
I try to emphasize it by putting it over here while conducting statistical investigation. So I assume that as much as possible in each and every step, maybe not in the first one, maybe that's just, but that students do statistical investigations going through the entire empirical cycle, starting from a research question invented by themselves or given by them by the teacher. Yes, definitely. Yeah, I think should always be framed in a meaningful question, for the students' meaningful question.
yes, but I think the steps that are there and what we see there on the board are specifically focused on the part of variation, but I think the whole cyclus is much broader.
Indeed, yeah.
And in every part you have your specific inferential view on it. So maybe that should be incorporated in.
That's a good one. Yeah, I embed this learning path within general recommendation for statistics education. Right, there are a number of general recommendations, like let students collect their own data or go through the empirical cycle, meaningful. I can't list them right now, but that's what I take as a starting point. But that's for statistics education in general. Okay, now what if you want to teach inferential statistics? What extra design principles, extras do we have to add? But I think I think your point is correct. It's in the learning path, it becomes maybe too technical, right?
Yes.
And too much focused on one part of the cycle, missing some of the inferential issues in the other parts of the empirical cycle.
Yes, and also your problem indicates what kind of statistics you need to solve that problem. So they are very much connected.
Yeah.
So that's something I think you should.
Good point.
You could.
I'm going to
embed
consider that.
in your.
Yeah. Thank you.
So it's like you have put here goals for teaching, but not put goals for students that they solve by these tasks.
I've tried to have the titles are the activities, I would say, and these are the student goals.
This is what teacher wants from students as a result.
That would be the learning objectives.
Yeah, learning objective. But what would be the task for the student herself within this activity? I think this is what Miranda was trying to say.
Okay,
yeah?
What would the task?
Yeah, at each level you could try to follow. Yeah.
For the students, it should be valuable to use statistics. So.
Mm-hmm. And that's more than.
To become more.
You would argue that's more than putting it in a context of statistical investigations.
Yes, maybe.
Good one. Yeah.
Yeah, I was thinking about the goals for primary education. You want to stay at a very informal level.
Indeed.
And that would mean.
I suggest, I'm not sure about that.
Sure, I mean, it's, So, so it comes down to understanding that if there is in the media something like 1/3 of the kids were questioned and that were questioned said something and so on. And they should ask also about, well, okay, then it's important to know how many kids are questioned.
Mm-hmm.
And the more kids are questioned, the better.
Mm-hmm.
It is probably, well, it says more. So that's a very easy thing, isn't it? I mean, it's very, or is it something, is it hard for kids to understand this? I mean, do you really need a lot of real activities for this, or is it just that if you have some discussion about this point, about this thing that's in the media, then the kids will already come up with, 500. could be 1,000 would be better, and so on. So is it the real hard thing? As long as you stay on this very informal level, is it something they have to overcome, or is it a new standpoint for them?
Well, what I experienced when testing the lesson myself and observing the pre-service teachers teaching that lesson, that primary school students are reluctant to accept the possibility of making an inference when sample results are very close to each other. I'm just phrasing it correctly. When the number 1, the, and the number 2, he, are very close together, then they are reluctant to make an inference about a whole pile of books. So I think it's difficult to understand. They understand that different samples give different results. So how can we use one sample to make an inference? I think that's a conceptual, difficult question. And of course, one can say, let's sample more books or more children, but then we can go on to the entire population of children of books. So at some point, we want to stop. And at what point? When is the sample large enough? And that's to understand that at some point it is large enough, because results converge, that's difficult. And I even sometimes think it might be too difficult for primary education.
Yeah. So would you come to numbers then, to say, well, 500 would not be enough, but let's have 1,000? Is it something?
I pragmatically chose for 1,000 because in many situations then you see that the interval is very small, so you can somehow make just a point estimate. You don't need to interval estimate. And also because many polling agencies often use 1,000 as a sample size. So that would be for primary education, maybe the take-home message. And then the secondary education, you can go on and say, yeah, we can take a smaller sample, but then your margin of error, your uncertainty expressed in your margin of error increases.
But would it be enough if they just say, well, okay, it could be the or it could be he? Well, we don't know yet, and we would have, if we had a larger sample, it would be okay. So
yeah.
Is that a difficult
thing? An example of the pile of books is not really, it doesn't really matter what word is most frequently used, right? But I set it as an exploration to find an answer to the question, how large should the sample be? And how does it work, that sample-to-sample variability? Can we indeed say that 1/3 of the parents is addicted to the smartphone? So I think it's relevant to discuss this issue, how large a sample should be, yeah, and how it works.
Yeah, but you would not come up with a final answer on that. You wouldn't give it. You wouldn't come up with a final answer saying, well, 1,000 would be enough, and 750 would not be enough. I don't know yet. I mean, because you
I would give the answer
that.
Sorry?
You're leaving out the technical things, the computation.
Yeah. I think I would come up with 1,000. Yeah. But in this pile of books, the number of words is not that clear, the sample size. But the underlying logic, that's what I want to stress, of course. As long as the larger your sample is, the closer the results are. That's what we are exploring.
That's what you hope.
Sorry?
You cannot be sure, but that's what you got.
Yeah.
But you wanted to connect to this, right? Okay, then please do it, and I will later.
On the other hand, when the sample size is very low, take 5 or 10, have you any experience with that? Over generalizations about on a very small sample.
I do have. In my second study, I had a very small sample size, 4. And what did students do then? Well, in that study, they still ignored the inferential part. But, I don't remember what kind of reasoning they gave. Some were just, I think the majority, when the sample size is very small, I used 4, they just refused to make an inference. it's too small, which I think is, on the one hand, is a sound strategy. On the other hand, he can say something based on the sample 4. It gives more information than no information at all.
Because in the public debate, n is 1 is a very strong argument.
Indeed, yeah.
It's
Yeah. Then you relate back to data as evidence,
yes.
right? And related to fake news as well. Yeah.
And n is 2 is even stronger. My neighbor said it's...
Yeah. Of course, that's the societal background of inferential statistics. Yeah. And therefore, I think it's important that all people encounter it to counteract that kind of reasoning. Yeah. NS1 and NS2 reasoning. Yeah.
Hi, thanks for your talk, Arjen. I would like to discuss another topic compared to the previous one. Your schedule, which looks very fancy and nice with the colors, but I have a bit of a concern, or maybe a question or a challenge. It's maybe not that hard to add things over the ages and primary, secondary, higher, and so. So that's clear what you add. But what happens with the things that stay, like for example the green one, analyze examples in media, that pops up from primary up to higher. So what I think the main challenge might be to assess what is different in analyzing examples in media in higher education compared to primary, because you don't want students get the feeling, okay, I've done this already 4 times over my school career. And in algebra, for example, this may be easier because you say, okay, we go from linear equations to quadratic and to exponential ones, and for variables we have unknowns. And so in some topics it's very clear how things proceed. But my fear is a little bit that in this, if we think of curriculum development nu, for example, the Dutch curriculum reform, over the school career of a student, how do we pinpoint what is added in the things that are remaining? And I think this is probably a bigger challenge than setting up the scheme as a whole. So what's your opinion on that?
Siska wants to react to that?
You can go first.
I think it's a good point anyway. My idea about that was that on part of the teacher they asked different questions. So, for example, in higher education, they know what they have encountered in secondary education, something about sampling methods, something about sample size, and they can say, write a critical report and pay attention to what they pay attention evolves over the years. And on part of the students, I hope that they use the previous learned knowledge in the critical report.
Yeah, well, of course I see the power and the need for repetition.
Yeah.
But I think we should try to be very explicit on what is added to this within these same colors.
Yeah, good one.
Otherwise, there's a danger of it getting very dull.
Yeah, indeed. Yeah, fully agree. And one more complexity is that primary education, the teacher gives the example. In the media, secondary education, they look for the example. The students look for the example themselves. Things like that.
Yeah, but what's happening then? What's then conceptually? What's the learning difference? That's important to pinpoint, I guess.
Good one. Yeah.
Yes, my question relates to that, in that I was wondering how the different blocks of the learning path relate to each other, especially in size. So, well, there's actually 2 questions I have. One is you don't say anything now about the relative importance or size of the different components, and I was wondering whether you do have, you probably do have ideas on that, so I was wondering if you could say something about that. And the second is, I'm especially a bit doubting about the yellow block, the exploring sampling distributions, because, well, you said it's ending a bit strange, a bit theoretical.
Yeah.
So I was a bit puzzled, should you keep doing that, or should it be something that students should have seen once? But could you would it be possible to end that at some point and say, okay, we've seen this, we know now what the idea is, and we're going to the simulation-based inference, and stop looking at our population, because the point is that we don't know our complete population.
2 questions. Yeah, the first one is about the relative size, and I think that the farther you get, the quicker it can go. For example, exploring sampling distributions, it can go in higher education very quickly, right? And it connects to your second question. Should we repeat exploring sampling distributions? Well, the reason why I put it there is that, for example, in simulation-based inference, and actually in most statistical textbooks for higher education, they start with the sampling distribution based on repeated sampling, right? And therefore it's there. And maybe you shouldn't start with manual sampling in higher education then, although you do that for bootstrapping. So I think at each level you should have an experience of manual sampling, either repeated sampling or bootstrap sampling. And for example, for vocational education, who ends after the second building block, I think the learning objective would then be that's how it works in practice, right? Of course, we don't know the sampling distribution. I'm thinking aloud now. Of course, we don't know the sampling distribution, but what we see is when we should do it, it works, right? In some way or another, we convince students at vocational education that it works, right? Under some circumstances. You need a large sample. It should be well selected, something like that. And you hope they take that with them in their personal lives. Does it answer your question?
Yes.
Okay.
Thank you.
I have a short question concerning also what changes, and even more, at the beginning you start from analysis of examples in the media before any conceptions of statistics come in. Mm-hmm. And I wonder what kind of analysis you can conduct, what kind of questions you can raise with the students.
At the very beginning with primary school students, I think you build on intuitive notions about sampling, about sample size, what is a good sample. And I think in the whole class discussions, teacher can very well raise issues like, when we only sample children from Amsterdam, would that be a good sample? Or rich parents or whatever, right? I think primary school students from very early age onwards have some intuitive notions related to sampling issues. Yeah, and it requires the teacher to ask these questions, of course.
Yeah. So you somehow assume that there is intuitive knowledge before, just in real life, and then by this explore sampling distribution, they will kind of clarify their intuition on examples. Can I say this way?
Yeah, I would say so. I think they also have an intuitive notion that a different sample results in a different result. Yeah, and then from that, based on that notion, you're going to building block 2, indeed. You're going to explore how it works. Mm-hmm. Yeah. Mm-hmm.
Thanks.
Maybe it would be helpful to describe the different kind of problems you really want to solve on the different levels. For instance, comparing 2 groups concerning the mean or something like that, or the relation between 2 variables. And probably when on each level you describe some prototypical problems, it would be helpful to make clear what kind of progression is intended here. Yeah.
Okay, and Miranda, last question or comment?
Okay, maybe another way of looking at building blocks and progression is, you said it yourself, that there is a large scale between informal statistical inference to the more formal way. So you want to start informal and become more and more formal. So to quantify things going on the way towards formal. So you can do that on different levels. So we have here the building blocks. I'm not sure whether this should be the 4 building blocks. I think it's good to have a path that says where you come from, where you want to go to, and the different steps in between in different themes about comparing groups of hypothesis testing and so on, but also in the informal approach to the formal approach. I think that's the part you want to go, the path you want to go, and explore sampling distributions and the blue block, the 3 simulation-based inference, is very close together. I think
overlapping.
So yes, so maybe they shouldn't be 2 blocks, but maybe 1 block that's growing or going to another color from informal to formal.
Because
so maybe
simulation-based inference, I suggest also do some manual repeated sampling. And simulation-based inference is actually also simulated sampling.
Yes. So maybe the structure can be more.
Could be improved.
Or just another way.
Okay, thank you very much, Arjen, for the presentation and triggering all our collective thinking process. I think that was productive. Thanks a lot.
Okay, thank you.